Okay, a concept we're going to need to understand very well to prove Ptolemy's theorem is the idea of similar triangles. What similar means is that they have the same shape but different sides. And what same shape, mathematically speaking, means for triangles is that their angles are equal. So these two triangles are similar because angle A equals angle X, angle B equals angle Y, and angle C equals angle Z. And we write that with this notation right here. Triangle ABC is similar to triangle XYZ. And since triangles have 180 degrees in total in all of their angles, we only need to know two angles to determine what two angles to be equal to determine whether two triangles are similar. Since we can just subtract the other two angles from 180 to figure out the other one. This is called the AA or angle-angle criterion. A reminder of a couple other important things that we'll need to show an important theorem in a moment. That if we have a parallelogram, ABCD, then we have that AB is parallel to DC and AB is equal to DC in length. And one other thing is that if we have two parallel lines, these two, and another line that crosses them called the transversal, it's going to create various angles, and these angles, Q and R, are called alternate interior angles, and they're equal in measure. Okay, the important thing we're going to need for Ptolemy's theorem is this other theorem, that if we have two similar triangles, ABC and XYZ, then their corresponding sides, meaning sides that are opposite equal angles, they follow this proportion, that AB over XY is equal to BC over YZ is equal to AC over XZ. To prove that, though, we're going to need a separate result, this lemma. A lemma is basically a less important theorem. Okay, basically it says that if we have, in this triangle, we have a triangle ABC, and we pick a point U on AB and a point V on AC, that if we have UV is parallel to BC, right here, that is equivalent to saying that AU divided by AB is equal to AV divided by AC. Okay, now to prove this, let's start by defining these two variables just to keep the math cleaner. Let's let alpha be UB divided by AB, and beta is going to be VC over AC. Okay, now just by looking at this triangle, you can tell that AU is equal to AB minus UB. And using our proportions here, that means that AU is equal to 1 minus alpha times AB. And in a similar way, we have that AV equals AC minus VC, which is equal to 1 minus beta times AC. Moving a couple things around here, we have that AU over AB is equal to 1 minus alpha, and AV over AC is equal to 1 minus beta. So, if we want to show this, we can equivalently show this fact, that UV is being parallel to BC is equivalent to alpha equaling beta. Okay, so to show that, we're going to take a look at the areas of some of the triangles in here. All right, K here denotes an area, and the subscripts label the triangle. So this is the area of triangle BUC. Okay, so here's triangle BUC right here. Here's its height. And the area of the triangle is 1/2 base times height. And then we have area of triangle ABC. Notice that it's the same height as the BUC, and that's equal to 1/2 base times height. So if we divide these two areas, we're going to get UB over AB, which you've remembered a moment ago, we defined as alpha. And so if we take triangle BVC and go through a similar argument, we get that VC over AB is equal to beta. Okay, so we needed alpha equals beta. So we can get alpha equals beta if we have these two proportions being equal. Notice the denominator is the same in both of these. So we need area BUC is equal BC, and we get that if their heights are equal. Okay, so remember, we have that UE and VF are parallel, which they have to be since they're both perpendicular to BC since their heights are triangles. And we have that UE equals UF, then this quadrilateral UVFE is a parallelogram. And so if it's a parallelogram, we have UV is parallel to EF. So just to recap, so we have that. If we have that these two heights are equal, if those two heights are equal, their areas are equal. If their areas are equal, alpha equals beta. And if alpha equals beta, we have that proportion like we wanted. And so we have to show, there's two directions to this condition here, so we have to prove the other one. If we have that UV is parallel to EF, or equivalently UV is parallel to BC, then since we already have that these UE and VF are parallel, then this is a parallelogram, and we have what we needed. Okay, now that that's out of the way, let's prove our original important theorem there about proportions. Okay, so let's take triangle ABC being similar to XYZ, we've drawn them here. All right, we want to show that that proportion we were talking about holds, that XY over AB equals XZ over AC. The other proportions will follow exactly the same type of reasoning, so if we can show that, then the other proportions will work too. So we have two cases. Let's say that XY equals AB. So let's say that equals that. Then, by a congruence criterion called angle side angle, if we have, since these are similar, angle A equals angle X, angle B equals angle Y, and if we take AB to equal AY, then the two triangles are congruent. That means that the length of XZ is going to be equal to the length of AC, and so if we do a bit of division with this and this, we get that XY over AB equals XZ over AC, which is equal to 1. So we've shown it for that case. The other case is if XY is not equal to AB. Okay, then let's pick a point U on AB so that the length of AU is equal to XY. And then let's pick a point V right here so that UV is parallel to BC. We have that angle AUV is equal to angle B, since we have two parallel lines here. This is a transversal, and these two angles are equal. And then these two are also equal to angle Y, since this triangle and this triangle are equal. These two angles are equal. In the same way, we have angle AVU is equal to angle C is equal to angle Z. All right, so we use three of the pieces of info we just got. AU equals XY, AUV, angle AUV equals angle Y, angle AVU equals angle Z, and we get, by another congruence criterion, SAA, side angle angle, that triangle AUV is congruent to triangle XYZ. So, move back over here. That means that if these two triangles are congruent, then AV equals XZ. Now, we have that UV is parallel to BC, which we constructed it that way. Then by that lemma we just proved a moment ago, we have that AU over AB equals AV over AC. But since we found out that AU equals XY and AV equals XZ, we can replace them in this proportion and get exactly the proportion we wanted. XY over AB equals XZ over AC. And the other proportions will follow the same reasoning. And there you have it.